Good afternoon, everyone. Thank you for joining for us for today's webinar on driving excellence end of line testing for electric vehicles. My name is Avantika Patil and I'm the host for your today's session. As many of you are aware that ISS is working diligently in automotive sector for past 25 years to provide an automotive testing solutions for major OEMs in India as well as globally. This webinar is specifically arranged to create the awareness and knowledge about EV end of line. So before we begin, we will go through the agenda first. So our session is structured as introduction to first end-of-line testing. The second is motor testing. Then we will go to transmission testing, and the last we will continue with vehicle testing. Now, in this, if you have any questions regarding to this, you can go in the chat box and you can ask your questions. So before moving ahead, I would like to give one a small company introduction. So we will go through it by company, showing the company's presentation. And just wait a second. And there is some technical issue. We will take care of it. Hello. As we are facing some technical issue, I think the voice is not audible for this. So we will play this presentation again in the end. Till then, you can go through this. Before we dive into the presentation, let me introduce to our first speaker. Shrikant Gundu is a BTech graduate from MIT Aurangabad with 10 years of experience at ISS Technologies. His expertise lies in product development for IC, vehicle, and EV testing, particularly ensuring compliance with global regulations such as Euro 7, WLTP, WMTC, and BS6. He has also collaborated with major automobile OEMs in India and abroad and worked closely with certification agencies for automation projects. Now, I would like to hand over the charge to our first speaker who will begin the presentation for today's topic.
Avantika. So before actually going into the presentation, we will set the context for today's webinar. So today's webinar is end of line testing. We will be going through the component level from component level testing to the system level testing, and it will include the procedures and the solutions which ISIS has to offer as a component manufacturer to you or as a vehicle manufacturer. So being a pioneer in the automotive field from last 25 years, ISIS has provided many complex solutions right from ICE testing solutions to the EV, and now we have jumped into the fuel cell electric vehicles also. So limited to today's webinar, we will focus on the end of line testing solutions for the motor level testing, the transmission level testing, and the vehicle level testing. So basically, as we all know, end of line testing is generally carried out to test the end product by any manufacturer to make sure that their product is performing as per their expectation from aesthetic point of view, from the safety point of view, from the performance point of view, which will avoid the field failures, and it will save their overall, it will save their time in overall product release as well. So to start, my team along with me will one by one present first the motor level testing solutions and the testing what we are offering. So it will include the high level presentation of the system architecture, the kind of testing solutions we are providing, and what advantages you will have if you work with us. Then we will go for the transmission level testing. Again, it will have some UTs definitions, the testing solutions, the system architecture definition, and the advantages of the ISIS as a system. Then we will go in the last to the system level testing, which is a vehicle. In the vehicle level system, again, we will provide the introduction to the testing solutions, testing architecture, the kind of facilities we are having, and the advantages if you work with the ISS. And in the last, we will collaborate and we will end with a slight introduction to our digital transformation platform, which will be having facility to integrate all these motor transmission vehicle test facilities to a server level integration, where you can perform your data analysis and the test scheduling level activities on a centralized platform. So to begin with, we will let's start with the motor level testing for the end of line. My colleague Rutuj will start now for the end of line motor testing. Thank you all.
Thank you, Shrikant sir, for the wonderful introduction. Now we will move with the second speaker, who is Rutuj Undare. Rutuj holds a bachelor's degree in mechanical engineering and master's degree in automotive engineering from Coventry University, UK. As a senior engineer at ISS, he specializes in developing advanced EV testing solutions, including motor, powertrain, vehicle testing, with expertise in transmission, EXL, battery, and motor emulators. Additionally, he is well versed in European and global emission standards, effectively integrating regulatory compliance in automotive testing and protocols. Now, I would like to hand over to the Rutuj for the presentation.
Thank you, Avantika, for this kind introduction. So henceforth, we'll deep down into one by one into all the other aspects of the end of line testing, starting from the motor. So motor is a driving unit of any vehicle. So there are many challenges production in which the customer faces in their production and performance level testing. But here we will see some of the challenges which where the end of line testing or the production testing will happen, and what are the test types, what level of testing we do, and what are the devices that we use during the testing. So one by one, we'll go through all those structures. So to start with, I like to divide this complete testing into two types. One is the direct testing and another is the indirect testing. So the main purpose to divide this is in the direct testing, what we do is we couple the motor with a dynamometer or a loading device, and we load the motor at its peak torque or peak performance value. So basically, we are loading it in its full capacity of the motor. So that's why we call it as a direct testing, where we test its efficiency of the motor. So in that, there are majorly the test performs are the peak power test, in which the motor has been tested at its peak power at various different speeds and how the motor performs. The after one is the peak torque test. So at the speed or the rated speed, how much the torque is being developed by the motor, that can be tested in the peak torque test. Similarly, in efficiency test, at different speeds, we get different efficiencies with different torque levels. So to map that, we have a separate efficiency test where a complete efficiency map can be generated in this testing. After that, the max RPM test, where your motor is being tested at their 10 or more than 20% of its maximum RPM, which is stated by the manufacturer. So let's say if it is a 1000 RPM max motor, then it will be tested at a 20% higher. That's at 1200 RPM. So just to check whether the noise or the vibrations are there and created in this testing. Next one is a frictional test, which occurs or which we take during after the assembly is done, when where we check whether there are any vibrational losses or any harshness or during the testing are being conducted. So we check that according to me. So next one is the indirect testing. So I just want to focus this on the indirect testing because majorly the indirect testing comes where the electrical parameters are majorly evaluated or checked. Because in this indirect testing, motor is never coupled with a loading device. We have to just rotate it in a certain RPM to check the electrical parameters such as resistance, inductance, voltages, any back EMF is generated. So that we can check the performance of the motor before it is assembling properly. So in this, this indirect testing can be done in many stages, like after assembling the rotor, or after assembling the stator and rotor both, or before assembling the inverter. So there are different stages where this indirect testing and the different tests can be performed. So to check that there are different types of tests, such as insulation resistance test, where you check the phase level of resistance and the insulations which has been generated in this motor. After that is the induced voltage test, where you check the no load voltage what is being generated, because we are just rotating that motor at certain RPM, that is 100 RPM, 200, 300, as per the manufacturer's demand. So once we rotate that motor at certain RPM, there is some amount of voltage that is being generated. So depending upon the voltage which is being generated, motor manufacturer has its own values. So let's say the motor is generating around 20 to 25 amount of 20 to 25 volts in this RPM level. So if it exceeds that limit, then we can say that the whatever motor which has been assembled is not suitable or it is not okay. So we can check that in the pass of norms as well. The next one is the open circuit voltage test, where similarly we do it on the induced voltage basis. The other one is the phase angle voltage, the phase angle test, where we check the major angle between the stator and the rotor. So in the next slide, I have briefly explained the three types of test and their direct impact on the motor assembly and the performance of the motor. Next one is the back EMF test when the no load EMF or induced EMF which is being generated in the no load conditions, whether to check the assembly of the motor is properly done or not. This is the basic architecture of the motor testing setup. So, depending upon the structure, this is the indirect or direct. There are many devices which are used because the devices plays a vital role in this testing. The separate voltage, separate power, voltage, inductance, or angle, whatever parameters we want to check, those are checked by the separate devices. So these devices are being completely integrated with the automation system. So let me show you. Yeah. So on the left and the right hand side, you can see the number of devices which are communicated with the automation system and which are directly connected to the motor. So these devices are connected in different ways, where they are connected in all three phases. A separate connector is connected to the motor. So depending upon the device structure, these are connected to the motor. So this motor is connected to a servo or a dynamometer depending upon how much RPM and how much torque you want to give. And this complete entire to run the system, we have a automation panel which includes a number of PLCs, servo drives, switch gears, and also as it is a production line, the main factor here is the time and the safety of the operator. So the complete cycle time we have to manage with all the safeties. So considering the safeties, we can use the light curtains where any physical object during testing cannot enter into the testing area, and we can stop the test immediately. So all these devices are being integrated with the only one automation system where we can see all those results and declare whether the selected motor is being passed on that particular norms or on that particular parameters or not. And when you test all those motors, you generate a report directly. So when in future, if we get a vehicle breakdown on the road from the customer side, so if you want to track those results of the motor, so directly you can track those with the help of the QR code or a serial number which will be scanned by this barcode. So this is directly connected to our server, where all those data results of the motor of the serial number is being saved under that serial number. So this is the complete architecture of the motor, where you can test a number of tests and check whether the motor is okay or not. So next was the benefits of indirect testing. Rightly I mentioned because once you completely assemble the motor, you have to check on the various parameters, and once you get failure over there, there is a lot of time where we invest in that. So to reduce the time and to increase the productivity, we can use these indirect types of testing in the earlier stage of assembly of the motor. So in this, the major parameters are the resistance of the motor. So the checking after to check whether the motor can resist at high voltage shocks and short circuits, insulation resistance. Testing is necessary that almost 80% of electrical maintenance and test involves this integrity of electrical systems. So when the voltage has been induced in this testing, it will directly influence the torque generation and mechanical power output. Sorry. So this is the very major parameter because doing the performance test as I did later stage, it's better to do the same testing at the earlier stage. That is the voltage test that where we can clearly know the motor can generate that particular amount of torque or the mechanical power. So the phase error measurement will show the proper angle between the stator and rotor is aligned or not. So this will help to know where the controlling of the electrical motor is proper, the performance of the power delivery and the efficiency, so that in future, if there is any error in all those conditions, we can directly map those errors to this type of testing. So these are all the devices. Some of the devices I can say which are used, such as power analyzer, where you can have a number of parameters such as phase voltage, phase currents, power supply, and frequency as well. So in performance testing, you need to power up the controller. So to power up the controller, we need the DC power supply constantly giving the power to the controller. And to check all the electrical parameters, we need the sensors which are integrated with the power analyzer, that are current sensors. So to check the other parameters such as the resistance, we have an insulation measurement. Where in this type of test, majorly I want to say, like the motor is been induced, or a high amount of voltage is passed through this device in within a fraction of seconds. And once that voltage is passed, we get a resistance value, and from that same device, we can get to know whether the resistance, whatever we have received, the motor is being okay or not. So from the similar device, we can check the motor is okay or not instead of going to the automation system. To check the angle or to check the phase measurement, we have a resometer measurement where you can check the angle between the stator and rotor, as well as the RPM of the motor, because nowadays the motor right now are assembled with the inbuilt reduction ratios. So the shaft RPM is completely different to the stator RPM. So when if you want to know the complete the original stator RPM, that can also be recorded in this particular device. Next is the induced voltage measurement, where you can have the voltage such as root mean square voltage, maximum voltage of all the phases, and check whether your motor can deliver that amount of torque which the motor designer has been designed. Another is the barcode sensor. So depending upon what type of QR code or what type of series barcodes are there, the barcodes can be selected as per the customer's requirement. So this is a standard report format what ISS has produced. So you can see number of parameters are involved here, such as resistance, voltage, phase, speed, OCV. So each and every parameters we have put a pass of norm depending upon the customer's requirement or depending upon the motor's requirement. So these are the required parameters, and whatever actual data during testing is being recorded is printed over here. So the software automatically tells whether your actual data matches with the required data, and based on that, the judgment is given of pass or okay or not good. So once all these tests are passed, you get a final results of pass. So if any one of the test is failed, the final judgment will be failed. So this can be customized as per the customer's requirement or any standard format if any customer has. So next one is I want to discuss about a use case what we have gone through and from where we got a lot of experience in the end of line system. So this is one of the system for motor testing we have delivered at a customer side, and the major requirement was a very less amount of cycle time and the ease of operations to the operator level and automate the test cycles. So all this has been achieved in very less amount of cycle time, because the cycle time plays a vital role in the end of line testing. So from the start of the loading, then clamping the phase wires, and then starting the test with any two-hand press button or any one push of button, the test will be automatically started. And once the test is started, the parameters will show a pass or fail results. So when you get all pass results, then only you can have a final judgment of pass, and you can stop the test. So this was a very nice experience what we have gone through for the motor testing. So this was some insights of the motor testing for end of line solutions. So in the further slides, I would like to invite my colleague Mr. Akash to start with the transmission testing. So we'll see the types of transmission and the test types in the further slides. Thank you.
Thank you, Rutu, about motor testing. Now, Now we will move with the next speaker, who is Akash Kate. Akash Kate holds a bachelor's degree in mechatronics engineering and has 3 years of experience in research and development within automobile industry. As an experienced mechatronics engineer, he specializes in integrating mechanical, electronic, and software systems to innovate and enhance vehicle technologies with focus on improving performance and safety. He is skilled in cutting-edge research and contributes to the advancement of automotive engineering solutions, bringing a multidisciplinary approach to the field. With that, I would also like to introduce another speaker who is Tejaswa Soni, who holds a BTech in mechanical engineering and has 3 years of experience as a senior engineer at ISS Technology Solutions. Tejaswa specializes in various aspects of automotive engineering, including engine, transmission, electric vehicle motors, and control system design. He has expertise in gearbox transmission and design of fuel cells and controllers, contributing significantly to the development and optimization of advanced vehicle technologies. Now, I would like both of them to proceed with the presentations.
Thank you, Antika, for your introduction. So now we will look after the another key aspect of the EV is the transmission. So in EV, there are mainly three types of transmission. One is the continuous CVT gearbox, where the gear ratios are adjusted by continuously varying with infinite number of gear ratios. Second is the EV with two-speed transmissions, EV without transmission, which is also known as the hub motor, and EV with transaxial. Transaxial are mainly used in commercial vehicles and heavy duty vehicles. So first we'll understand like what is the difference between the mid-drive, hub and transaxial case. In mid-drive, the motor is mounted onto the frame of the vehicle where the power is delivered to the wheel via gears using the belt transmission. In hub motor is directly placed on the wheel where the power is directly transmitted to the wheel. Despite hub motors are more efficient on flat terrains and for daily commuting. Hub motors are also have low energy efficiency as compared to mid drives with the energy conversion ratio of 70 to 80%. In transaxials are mainly used in commercial vehicles. They consist of various different components on the transmission. So first one is the motor, second is the differential, then we have the gearbox. Transaxles mainly are used to deliver the power to the wheels in a more feasible way. These are the some of the major key differences between all three transmission drivers. So now first we will understand the simulation model, where we have the main aim of this model is to predict the energy efficiency and the power consumption of an drivetrain. So first we have the driving cycle imported to our model, which is the NEDC cycle, the main purpose of this NADC cycle is to verify the power consumption of the EV vehicle or any commercial vehicle. Then we also have imported the motor efficiency map of a particular motor type and using the manufacturer data. Also, we have used MATLAB and QSS tool to provide the data and predict the outcomes of the model. So here in this first graph, you can see this simulation is mainly used for select the gearing like in CVTs the gear ratios are changing continuously with infinite number of gear ratios. So here the main aim is to select the gear ratios, predict the gear ratios of a CVT. So here we have in first graph we have used a constant speed ramp up method, and in second graph we have used constant acceleration method. So as we can see that in first graph the gear ratios which are selected are not very much smooth, but nearly up to the mark. And in constant acceleration test, the gear variations of a CVT are smooth. These are the efficiency results that we have achieved by simulating the model. So in no gear EV, which is having no gear, or we can consider the case as a hub motor, the efficiencies are not more, like the efficiency is not maintained in a particular region. The plot is more scattered, and the energy consumption efficiency of the model is up to 88%. But if we look into the two-speed transmission, where the power and the speed and the torque are more gradually deployed to the wheel, and the efficiency results are much more improved in this case. So almost 93% of the efficiency can be achieved in this case. In case of CVT, due to the continuously variations of the gear, the CVT ensures the motor to be running in the optimum efficiency range in that case. So here also around 88% of the efficiency is achieved. So here are the some outcomes of the model. So here is the energy consumption of a hub motor. If we see as the energy consumption with the CVT, CVT has consumed the less power, and here are the improvements of a particular drivetrain with respect to CVT. So the next session, my colleague Tejaswa will continue, handing it over to Tejaswa.
Thank you, Akash. Thank you for the brief introduction about the transmission. Now now we will see about the system architecture for the transmission test rig, where how ISS will handle the transmission test rig. Here is our main software of Orbit, and there is an embedded controller which we have communicated, and there is a DAC modules through which we can take the signals for the torque or temperature and pressure. And from a CAN, we can communicate with EV motor via MCU, and we can give a demand to EV motor also. And in the meantime, we will send the demand to dynos for the in transaxle case. There is a left wheel and right wheel, both dynos are there. So we can send a torque demand or speed demand to left wheel and right wheel dynos also. And also, we can communicate with safety PLCs because there are so many safeties which we need to consider while doing the testing. these are the following tests which we are conducted on a IC test bench, like acceleration test, efficiency, motor thermal, on and RLS test, NVH, and on acceleration test, we will give the we will check the vehicle RPM from zero to its max full capacity within 100% of 100 with 100% of throttle in 1 second, and how the vehicle will act on the RLS test, that we will check that. And for the motor thermal test, we'll check about the thermal efficiency and like how the motor temperature will work on that. And for the RLS, there is a road load test on which we'll evaluate the vehicle parameters on the actual road conditions, and on that we will check about the current and battery voltages. And there is a next test of NVH. NVH is basically refer to the noise vibration, and this we will check on a motor test bench to check on a no load condition and loaded conditions also, which evaluate about the gears which is present in the EV. These are some simulations results, or the actual results which we have conducted on our systems. Like this is the acceleration test which we have performed on a vehicle and on a motor also. And here we have we got about the we have given the throttle in 1 second and checked the speed at which is at 0 RPM to its full RPM of full kmph of 80 km, full range of 80 kmph RPM. And on that we have checked about the acceleration, how the motor will react at a and standstill condition to its fly RPM. Now this is the RLS test, and on which we have conducted one WMD cycles, and this is the data for the WMD cycle, and here we have checked how the how the cycles will work on the its acceleration, like whatever the whatever the demands we have passed in a WMD cycle, at WMD cycles how the acceleration will work on that. And here we can see from standstill condition to while doing the ramping, there is sudden acceleration which is acted on the vehicle, due to which torque is higher. So we can see in that graph also that torque values are higher in the time in the starting of the vehicle, and after that, while it is running at a constant RPM, there is no acceleration, so the torque will also be reduces. This is the transaxle case data. Here we have sent a speed demand to our motor and a torque demand to both the wheels. Here we have checked about how our system will closely integrate with the demand and the feedback. Like we have sent RPM demand to motor, and on the both the wheels we have changed the gears, and after gears changing, how the demands will follow the feedback. Okay. For the next session, I will hand over to my colleague, Mr. Shrikant.
Thank you, Tejas. So as of now, we as you might have like understood, like we have initially checked gone through the component level testing, like which is motor level testing. Then we gone to the power level power like the transmission level testing, powertrain level testing, which and what is the ISS offering in terms of both component level and powertrain level testing. And now third and the last session, we will go through the system level testing, which is the vehicle And while we are doing the vehicle level end of line testing, what ICs has to offer you as an end of line testing solution, and what are the advantages if you go with the ISS testing solution. So basically, as we discussed initially, the end of line testing is generally done for with some basic purposes. Few of them are like the quality assurance to make sure like your end product, which is the vehicle, is having the basic quality checks before going onto the field. Like it might be from the like aesthetic point of view, it might be from the technical like the performance point of view, it might be from the safety point of view as well. So which will help you to improve your quality and to ensure that the end product is performing as per your expectation. Then the another few aspects are like the performance validation, as I discussed just now, the safety compliance, the functional testing, like the vehicle is working as per the given as per the design specifications. Then to ensure the product which you are offering to the end user, which is in this case is the customer, which will be using the vehicle on day-to-day basis, and he's having he's having the good end product which is giving consistent performance. And another purposes are like to collect the data of your end product and to analyze it might be the repeatability of the end product, and it can be used as a part of improvement, as a part of product improvement as well. So next point we will discuss is the system level architecture. This is just a sample architecture which we are presenting right now. ICE has offering of two-wheeler, three-wheeler, and four-wheeler up to HCV kind of level end of line testing. In this presentation, we are showing a basic two-wheeler end of line testing system. This is just a high level architecture. The actual system may be having number of stations which might where we can perform number of testings. So just to start with, as you can see, if we start, there is a field assembly which includes maybe a transient three-phase induction motor along with the twin roller assembly, which is connected to the AC dynamometer. The dynamometer is having a torque sensor, which will collect the actual load signals, and it will be transferred to the automation systems. The, through the encoder, we will collect the actual speed data, and there are some safety interlocks as well, like the wheel clamping, then uh, the pneumatic braking assembly, and the proxy sensors. So basically, the core part of this system will be this automation system. This automation system will include the host as well as the controller. So in the previous two solutions, what we explained, like the motor level testing solutions and the transmission level testing solutions, the core part of all these three systems is the ISS host automation system as well as the backend controller. So to explain more about this controller, these two products are indigenously developed by ISS, and these are the real-time systems. So to simulate the road load level conditions, the controller which is actually simulating the road load level simulation, it should be very accurate and fast in terms of its response. So the automation system which we are including, which we are having, is having that particular component. So our controller will act as at an accuracy of 10 milliseconds or better. So you can basically control your speed and torque demands at that particular accuracy level or at that particular time instance. So basically, the automation system will collect all the field data. Here in this automation system, you can create your UT models. You can create the pass of norms parameters. The tolerances for each and every parameter can be given, the safety interlocks, and basically the system safety interlocks and their actions. Suppose if you are having any particular safety interlocks for maximum speed, maximum torque, and if any of these particular safety parameters exceeds their prescribed limit, the system will act, and the particular action like the system shutdown, system idling, or the warning, such kind of actions will be taken by the system. So the automation system will again can for in terms of your digital transformation can be connected to the IS's provided server database, or it can be integrated with the third party server as well. So after this, I'll just skip this slide because I already explained the basic components of the chassis dyno for the end of line. So next, this is one of the sample test sequence which we can see can be performed as a part of your vehicle end of line testing. In terms of four-wheeler testing, this might or two-wheeler testing. Basically, first we will check out the front will and it will be having some acceleration testing up to the maximum speed. Vehicle will be accelerated. We will check the particular distance, the acceleration time, and to check the braking. The braking will be done maybe manually or through robotic robotic actuators provided by ISIS. And basically the system will calculate the braking force, time, distance, and these parameters will be actually compared with the reference parameters, and based on that the pass or fail judgment will be made by the system. Second will be the rear wheel testing. In this case, the testing will happen on the rear wheel. The rear will be accelerated at a maximum speed. Again, we will check the maximum speed, the acceleration time to reach that particular maximum speed. The distance will be calculated, and after the particular stabilization time, the braking will be done by on the rear wheel, and we will again check the braking force, distance, time to reach a particular stopping speed. So this is just one simple sequence which we can perform, but we can perform many more tests in terms of end of line testing for the vehicle. Like given in this slide, it might be the acceleration test, and as I just explained, the acceleration test basically can be performed to check the time for which vehicle is taking to reach from 0 to 10, 0 to 20, 40, 60, or 80, whatever time speed intervals as per the customer requirement. Second will be the brake test. During the brake test, we will be checking the braking force, distance, and the time for the deceleration. The speedometer test, just to ensure the vehicle and the roller speed are matching, the speedometer check will be done. The gear testing or the transmission check to check if the vehicle is reaching to that particular reference speed for each gear. We can perform the gear test. The RNS testing is to ensure the simulation, when vehicle is driven on the road, we are able to simulate those conditions on the chassis dyno. As I explained, our controller will make sure this RNS test is performed within with the proper accuracy and the control. The cruise control check or the hill check is nothing but if you are will be with the particular gradient. We will do the will provide some additional force by the vehicle, and that again reference the resistance force will be compared with the actual force. The drive cycle simulation is nothing but is repeated by the RLS. The safety verification like the ABS, if the vehicle is having ABS, so we can check it is getting activated and performing as per the expectation with the particular conditions are activated. So in this case, IS system will activate the ABS system through ECU communication. It will give particular command so that ABS can be started. It will check the feedback of the ABS system, and it will check if the ABS is working as per expectations or not. The electrical system check will can be some visual checks or some sensor feedback based automated checks to check all the electrical components on the vehicle are performing as per the expectations or not. Energy consumption test can be checked to, it will be done to verify the energy consumed by the vehicle during that particular cycle. The beam test, steering angle test can be performed on the different stations or the same station, and the data will be collected on the same automation system. So these are few of the tests. Apart from this, is if the customers or the users are having any custom requirements, those requirements also can be met by using ISS provided systems. So these are few field data which we would like to present here. This will show the how accurately ISS controller will work to simulate the road load conditions on the chassis dyno. The first one is the efficiency graph, where we can calculate the actual and the demand roll forces at the different speed levels. The second is the acceleration graph. It will show the again the theoretical force, the actual force applied by the system, and the particular speed level. So from this you can see that the response of the system is very important to simulate the road load conditions on the chassis dyno. Again, as we discussed earlier, we can provide a different kind of report format. It can be a standard format provided by ISS, or it can be custom formats which as per the customer requirements. Or we can go to the next level if customer is having some MES integration or some server data integration requirements. We can do that part as well, because ISS has done server integration with their own with our own bridge data management system or with the third party server system at many places past few years. So what are the advantages if you go with the ISS system? Uh, as we told earlier, like the complete test processes are automated right from the UUT transportation till the report generation and till the data analysis. Each and everything can be done automatically. Ease of use right from the operator level users till the management level users. Everyone can use these systems very efficiently and very easily. And one more thing is you can configure the test sequences parallelly to the test execution, which will increase the efficiency of the test bed utilization. The downtime will be very less. The adaptability of these systems is very high, which adaptability is the ability of these systems to adaptability is the ability of these systems to adapt the customer new requirement in terms of the integration, in terms of the new test sequence modification. So these can be done very easily with these systems. Uh, the resources by as the systems are automated, the resources use of resources is very optimized. The safety protocols, the it might be system level safety, it might be application level safety, or some data safety. You can configure user level authentications. There are some hardwired safety interlocks as well. So based on the user, we can provide some application access to each and every user, which will ensure that the data which is generated through these systems is kept secure. And the last not but not the least is the digital transformation, which I explained earlier, not just for the vehicle chassis dyno system, right from the component level testing to the transmission testing and the vehicle testing. It doesn't matter what kind of test facilities you are using. All this data can be integrated with a server, and we can do the test scheduling, we can do the resource management, we can do the maintenance activities, we can schedule the maintenance activities, and we can do the automated data analysis with the integrated server, which is again we call it as an end-to-end solution, wherein you are automating test sequences like that, right from the test scheduling, test execution, data generation, data analysis. Each and everything is automated. So ISS is nothing but providing the end-to-end solutions to its user. So that's all from my side. Thank you very much for hearing patiently. Now we can move with the question and answers. No. We have one question from Aman. So in case of two-wheeler, how to do the acceleration test? So Aman, if I'm correct, you're asking the acceleration test in terms of vehicle end of line testing. Please raise your hand if my understanding is correct. So in terms of vehicle acceleration test can be performed in two ways. It might be the distance based, or it might be the speed based. Okay. So in terms of the distance, you can provide distance as a criteria to reach the particular to cover the particular distance, how much time the vehicle is taking. Based on that, you can calculate the required acceleration time, and you can provide some intervals like zero point 0.1, 0.2, 0.3 kilometers, and you can provide your end criteria like from 0 to this particular 1 kilometer, how much time is vehicle taking. So our system can provide that solution to you. And second will be the speed by using the speed acceleration test, in which you can provide the speed intervals, say from 0 to 10, 0 to 20, 0 to 40, 0 to 60, like whatever your vehicle max speed is there, we can calculate the time interval and distance required to cover to reach that particular speed. So like this, we can do the acceleration testing in terms of two-wheeler vehicle. नेक्स्ट क्वेश्चन का है यार, है ना, अनम्यूट करके. He's asking please elaborate on NVH test on the transmission. So the NVH test is nothing but the noise, vibration, and harshness test, which we can perform on the transmission. In this case, like if the customer is having particular set points, that test sequence can be configured in the automation system, and those particular set points, it may be a particular speed or torque set point, and our system by using external DAQs or the sensors, our system will get the noise, vibration, and harshness data, and we can compare that data with at those particular set points if it is within your acceptance level or not. Next question is from the same. Apuntika is going to unmute you. You can ask your question. Hi, Apuntika. Okay, Nasreen, can you ask your question? Hello. Nasreen, you need to unmute your mic. Nasreen, I think you are having a problem with your mic. Please let me know if I'm correct. You are asking about the vehicle, different vehicle modes and the road conditions. So basically, if my understanding is correct, you can actually activate that particular vehicle mode if it is eco mode, sports mode, or maybe some other different mode which your vehicle is having. And we can activate these modes through our CAN communication and through our control system. And by having by putting the vehicle into that particular mode, we can do the vehicle level testing. And the road condition test. This in this case, if you are asking about the different road conditions, you can create the different actual drive cycle sequences in our system. It might be like if you are having standard sequence, it might be like the IDC. Also, you can create some custom cycles. If you are having some custom data collected by on-road driving, you can create those road cycles in our applications, and you can test on the chassis dyno. Okay, so you're having two more questions: how we can test as per the climate, motor, and controller performance or behavior, like overheat. So in this case, Nasrin, we will need to integrate the climatic chamber on your motor test bench. Basically, there will be, along with your speed and torque set points, you can define the temperature conditions. It might be transient temperature conditions, or you can test your motor and controller at particular constant temperature. So you can do this by having a climatic chamber integration with our automation system. So basically, you can configure your test sequence along with the climatic chamber integration. If so, after Nasrin, we got one more question from Aman. We are having one more question: is what is high beam test and the procedure? So, Aman, in the end of line testing, we are having actually these beam testing equipment in which you can do the vertical as well as horizontal alignment of your beam, and you can test the intensity of those beams as well. So if it is within that particular reference level, both horizontally and vertically, and the beam strength is as per the expectation, you can say your lighting is working fine. Okay. Next question is, can you say about frictional test? I think if anyone is having question, please unmute your mic and you can ask the question directly. We'll be happy to answer you.
I have one question. Do you hear me? Hello.
Hello. Hello.
Able to hear my voice?
Yeah, we can hear you.
Yeah. See, you have shown one test, acceleration test, brake test, speedometer check. So how these you will have a complete setup, or suppose if we are making IC engines, so we have an RBT test. There you will integrate.
Which test? RBT? Oh, hello.
Yeah, this is RBT
Can you
means
repeat?
roll and brake testing machine. So vehicles
Okay.
presently IC engines are tested there. All the parameters, acceleration, brake test, everything. So for electric vehicles, how you are going to test these parameters? Do you have a complete setup, or are you going to integrate with our existing setups?
Yeah, as I told in my presentation, actually we shown the architecture of the chassis dyno, but with that you can have your multiple test stations. So maybe on the chassis dyno you will be doing the acceleration and the performance testing. But for other testing, like as you told, brake test, if you are having some existing test station, it can be integrated with our system test system, or we can provide you a complete turnkey system for your testing requirement. But apart from that, if there are any other testing, like the I just told about the beam test or some steering angle test, power test, we can do the complete test station integration with our testing systems. So along with the chassis dyno, there will be different testing stations, and it will be integrated with one testing system where your complete data will be collected.
Okay.
Thank you, Purushottam.
Hi, this is Sanath here.
Hello, hi.
Hi, actually, my question is, I suppose actually we have built a vehicle, two-wheeler, and it's electric vehicle and it is having a transmission, okay, and a two-stage gearbox, and the vendor is claiming that actually the gearbox can improve the range of a vehicle. Is it true? I just want to know, as per your experience, as you have been tested so many vehicles with the gearbox, is it true that
Yes, sir.
actually it is going to improve? the range of a vehicle?
Yes, sir. If the gearbox is used, it significantly ensures that the motor runs in a optimum RPM. So
Okay.
whenever the motor is operating at optimum RPM, it does not consumes that much power or power while driving.
Okay.
So if you want to explain in a example that if we run the vehicle like we are climbing up a slope, but in case of hub motor, the hub motor will consume more energy, but it will not deliver that much power. But in case
Okay.
of two-stage transmission, the torque gets multiplied on the vehicle, so
Yes.
it will use the less power but deliver the higher torque.
Okay. Okay. You mean to say this is how the range can be improved, right? Hello?
Yes,
Yeah,
sir.
that's right. So, Sanat, basically the energy consumption will be less in case of two-stage transmission. So that's why it will improve your range, overall range.
Okay. Okay. I got it. Thank you. And one more thing is that actually, suppose, see, we have developed a vehicle where we have already chosen a suspension for our vehicle, and we need to see how the suspension does this performance. And is there any test with you guys to test the suspension performance?
Like sir, the vehicle that
Means
we have developed is a model.
means actually the thing is that how well the suspension is working, whether how well it is damping the road shocks.
Sanat, is there any your problem statement? Can you share that with us? We can share share you our communication details, and we can have a detailed discussion about this because basically the suspension performance we will need to see how we can collect the real-time data during your testing or when your vehicle is getting driven, and we need to check how we can collect that data in the real time and we can do the analysis. So maybe we can discuss this in detail.
Okay, fine. Thank you.
Thank you, sir. So Suraj is having one question: how emergency switch is working if we press during testing? So I already answered in the chat box, but still will answer we are having basically safety interlocks integrated with our system, and these interlocks are multi-level. It might be some warning level interlocks. It can be some actions if there are some severe safety interlock happens. So our system will basically automation system will tell the PLC safety PLC to act and to bring the system to the stable condition. So Nilesh Devgare is having one question in the dynamo. Oh, okay, it is also answered in the chat box. So we can actually monitor the battery temperature by doing the BMS integration with our system. And if there are any any temperature level exceeds, our system will basically flag up that particular parameter. Any more questions? If anyone is having any question or doubt, or anyone you want to know about the solutions provided by ISS, you can contact through our communication mail ID. It is Shadab will throw a mail after this session to all of you. And we are planning one more webinar maybe next month. It will be dedicated to the digital transformation. So, and again, we are planning some dedicated sessions. Like today, we just explained you about the high level system architecture and the test methodologies which we are using for component level to system level testing. But we can go in deep and we can discuss about the each and every testing solution in detail in upcoming days. If you are interested, please do provide your feedback to Shada, and we will be happy to arrange more webinars in coming days.
Yeah, just one query.
So,
hello.
Yeah, please.
Yeah, so it was nice presentation. Thank you for that. But I wanted to have a in-depth understanding for body end of line testing. For example, beam setting or power window and all. So is it possible that if you have anything specific on this aspect, you can pass it on?
Yeah, Prashant, if you can share your requirement to us, we can definitely provide you a solution on that. The beam testing, as of now, as we told, is definitely possible. The other testing requirement, what you are asking, if we get some details about that, we can definitely help you in that requirement.
Sure, sure. I will pass on. Yeah.
Sure. Thank you so much. Thank you.
So, hi Ritu. I have one more question here, like about the transmission. Okay. So, usually the two-speed or the single-speed transmission. So, what is the cycle time we can consider, like for the testing from loading the system to the final testing, considering the ramp up, ramp down cycles, whatever. What is the usual cycle time you consider for that?
Basically, cycle time will vary. What kind of right from the transportation system? Maybe if you are doing the manual transportation of your UUT, if you are doing the rigging and the UUT preparation activities manually, or if you are doing those activities automatically. So if you are using the automatic UUT transportation, UUT like preparation or UUT fixtures, it will have particularly very less time in your uh, uh, the test execution, loading and unloading. If you are doing the manual loading and manual unloading, in that case the test cycle will increase. And again, the test cycles or the your test sequence which you are using, the amount of time you are using for your test execution, it will also add up. So basically, it will vary right from your what kind of operations you are doing, if the manual, automatic, loading of the system, and the test execution cycle. These all parameters will add up to your overall test execution time. In case of automatic loading unloading, the test execution time will vary less, and in terms of manual loading and unloading, it will be more.
Yeah. So the point is especially the test period, right? Like so, in case of single speed transmission, what is the usual test period? The leave about the loading part and the detachment. So what's the test period you consider, considering the rank up or considering the reduction ratio mapping and all this?
So you are asking the actual testing time on the test rig?
Yeah,
or
only
right from
talking about the test period. Yeah.
Yeah, that's what I said. Like if you are having some particular set points in your test sequence, so basically the ramping up can be done within few seconds by the system. But based on your stabilization and the data acquisition time, in which you want to collect the data and you want to compare the actual results with your reference parameter, the cycle time will vary. So our system can actually ramp up the UUT to a particular speed or set point within a few seconds. It can log the data and it can compare the parameters, and it can show you the result within few seconds. But basically it will vary from customer to customer, from how the length of your how you are varying your cycle test cycle length.
Okay, okay. Thank you. So, in fact, like one more query, okay, like so about the transmission again. So, you mentioned, I think, in a chat box also, like, so about the NVH testing part. So, in case of some stage gear has a predominant frequency which is contributing. So, do you have an accelerometer to map, or you have like it's a method of sound measurement level or the vibration level? How you do that?
Yes, sir. Actually, for sound measurement, then for vibration measurement, we use accelerometers. Uh, so, like various sensors are placed there around the UT on the body, and from there we collect the data. So from there we sample out the normal frequencies and check with the abnormal frequencies to identify the noise issues there.
Okay, thank you.
Thank you, Sandeep. Yeah, Shadab has updated his mail ID in the chat box. Okay, I think Shadab will share that after the after the session. Uh, we will also share the feedback form along with the presentation after the session is over. Please do provide your feedback, and if you feel like anything can be improved, please don't hesitate to put that in the feedback form. Also, if you want to know about more about our solutions, you can connect with us through the mail ID which Shadab has shared, or you can visit our test facility here in Pune if you are in basically located in Pune. So, if there are no more questions, I think we can stop the session. Thank you so much for your time, and looking forward to have you with us in the future webinars as well. Thank you so much.
Thank you.